Most students say that integration is difficult, and others say it is confusing. But is that really true? The answer is probably no. Integration is actually one of the easiest topics we have in A-level mathematics, once you understand what it really means. In today's video, we will break it down step by step, and you will learn what integration is, why we use it, where it comes from, and how to solve integration questions easily with confidence. What is integration? Let's see. Before, assuming I'm having my rectangle with the sides, with the width, and with the length. So if the question says find the area of this rectangle, we all know that area of this rectangle is simply going to be the length times the width. So this is the formula of finding the area of that rectangle. I think this is very easy. This is very easy. Everyone knows this. So this will be the formula of finding the area of this rectangle. If we are required to find the area under the curve, look at this. So we are having our curve. I'm trying to make a simple sketch. This is a sketch. That is y-axis, and this is x-axis. So what if we are having our curve? Let me say that is our curve, which is f of x. So that is our curve, and we are required to find area under this curve. So the curve starts from this point, you can see it, and it ends at this and this point. So I can say the starting point, if this is point A, and this is point B. We are required to find the area of this curve, or the area under the curve. Are we again going to say that the area is so are we going to say that our area is equal to length times width? Are we going to say that area is length times width? The answer is no. This is not correct. Then how are we going to find the area? So look at this. So first of all, we have different ways. So firstly, we are going to divide, because our aim is to find this area. This is the area we want to find. Understand? So that is the area we want to find. So how can we get that area? So we can divide this area under the curve which we want into smaller, you can call it strips. We can divide this area into smaller strips. Let's say, so I'm going to try drawing. We can divide it into smaller strips. Let me say that. Okay, I think this is not so perfect. These are not so small, but let me add something. We draw very many, like that. Now what I'm doing, I'm trying to draw smaller strips. Now when you look at these strips, if at all I choose just one, at least each strip is trying to bring out the shape of a rectangle. So if I choose one strip, look here, so one strip is going to be like something like this. So it is something. So this is one strip. If I bring it from there, and you're going to see that this one is actually would be our x, but since the strips are very small, so we can say this will be our width, and this will be our length. But from the graph, this will be a very small distance, which is x, and still this one will be also a distance which is y. Now if we are to use the same formula we started with, which says that area is length times width, because that's what we saw in the first thing we looked at. So if we want to use this, we are going to say that area in this case for just one strip is going to be our length. We are saying it is the y, because it is on vertical axis, which is the y axis, so the distance, we call it y. So our area is going to be y, then times the width, which we are seeing as a small distance, which is x. Otherwise, so let's say that its y is just y1, just to separate. Can call it this is y1 and x1. So this is can be area 1. But remember, we are having a millions. It depends. The more we divide more strips, the more accurate our answer will be. I can say maybe area 2 is going to be y2, then small change in x2, etc, etc, etc. But then how can I find the area of under the curve? Because that is our target, is to find the total area under the curve. That means the total area under the curve A is simply going to be area 1 of one strip plus area of another strip plus the total strips. So you simply sum up the area of all the strips under the curve. So how can we get the total area under this curve? So at this point, I'll say we shall say integration. So I think we at this point we are now at the introduction of integration. So what does integration say? Like I said above, integration is simply summing up. Like from what we have seen, it is just summing up very many quantities in order to get one quantity. Like we have seen, we have to get the summation of all the areas of each stream in order to get the total area under the curve. So, and from the very above example, how are we going to get the total area under the curve? So the total area under the curve is simply going to be the summation, because our curve begins from point A to point B of what? Of f of x dx. So this is going to be the formula for finding the area under our curve. It's going to be the summation of f of x dx from point A to point B. So this is the general formula of integration, and this sign this is just simply a sign. This s, the elongated s you are seeing, this is the sign of integration, which is called the integral sign. So this is just elongated s. Why elongated s? Because we are simply summing up. So this is integration. We are going to have just one example. Let us see just one example. So how do we actually integrate? So let's have one example. So if the question says integrate 2x dx, as simple as that. Integrate 2x dx. So we all know differentiation, and in otherwise, integration is simply the reverse of differentiation. It is like when we are integrating, we are trying to turn what was already differentiated. So first step, we are having here 3 major steps under integrations. What do we do? So what we do, we are having our 2x. We are integrating with respect to x. First step, write the integral sign. Then of 2x dx. So let us see. Step 1. How are we going to solve this? Step 1. We have to know if we are having a number like our unknown is x, and we are integrating with respect to x. So what do we do? This x you are seeing here is to power. We look at the power here. For example, this x is having a silent power 1. Okay, it is to power 1. So if the question is maybe if it was 2x cubed, then our power will be 3. So we are so much interested in this power, as we are going to see. Step 1, look at that power. So what we do, simply and the easiest. So what we do, we are going to say you first write these 2 back, these 2, then you also write the x, which is to power 1. Okay, so when you are integrating, step 1, come to a power which is at this unknown or the term you are integrating to. For example, in our s it is x. Always add a 1 all together. So come to a power. If it is 2, it will be 2 plus 1. So this is all power. Understand? Then this quantity we are getting, for example, 1 plus 1, again divide it here, which will be 1 plus 1. So this is our integration. Then after we say plus c, where c is just a constant, we are going to see. So I said step 1, look at the power. Then after looking at the power, add 1 to the power. After adding 1 to the power, the total answer you are getting, again divide it by the whole thing. So this is going to be a 2x. So when we add 1 plus 1, it's going to be x squared. Then over 1 plus 1, which is a 2. Then plus our c. I said this c is simply a constant. In the next video, we shall see why we add a c and what is the use of putting a c after integration, or after integrating every question. So let us simplify. So this is going to be so you see, this is a 2 and this is a 2, so they will cancel out. I mean with x squared plus c. So that means the integral, we shall come and say the integral of 2x dx is going to be x squared plus a c. Is going to be x squared plus a c. As simple as that. In the next video, I'll show you why we put a c after every integration, and also we shall see substitution method and integration. Thank you. See you in the next video.